So this is the overview for Module 12. This module has formulas in it, and then it also has rate laws. So the left side, if you are very, very comfortable with formulas, you may be able to work your way through that homework fairly quickly because it really is mostly formulas. This right side has a little bit of formulas. It's a little bit of kinetics theory though also. And then you learn how to actually calculate a rate law from a table of values. So that has a little bit more in that section. So here's what the equations you'll be working with look like. You actually already know this equation. You learned that one way back. Let me find it. Over here. So you already learned, sorry, this one. So you already learned this back in Module 5. So not a new equation. So we're using that one. You're going to be introduced to this equation. So this is a new one because this is the first time. From last week, you learned how to calculate E cell. Remember, E cell was this calculation over here. So you'll have a lot of practice with calculating E cell already. So we're building on those two ideas. And when you have those two equations, notice they both equal delta G. And so you can say that this side is equal to this side, which relates E cell and K. So with these three equations right here, you can connect three different things. You can either solve for K or for E or for G. Just you can move around between all those terms. The R in this case is your 8.314, your temperature is all it weighs in Kelvin. This is a Faraday constant. This is the number of electrons in your system. So make sure that you write down and keep up with the ones that are the variables. Now this next section is kind of like expanding it. So you'll notice there's this portion. If you take this and you divide it by NF, so E cell divided by NF, you kind of get this term anyways. So Q is when something is not at equilibrium. So it's basically like any other point in the battery's life. And what you're doing is if you were to do the E cell calculation, it's kind of like saying, okay, it's not a perfect calculation unless you are perfectly at 1 molar concentrations and at 25. So what they did was they tacked on this kind of like a correction term that's kind of annoying. There's a second version of it right here that works at room temperature, but not 1 molar situation. So anyways, this is all those equations. So it's just plugging and chugging. If you like that, then you're going to like that section. And we move on over to this side. This is the kinetics, rate law, energy diagrams. If you had chemistry in high school, you would have seen energy diagrams. This is where like you figure out like this distance is activation energy and this distance is delta H, and if it ends higher, it's endo, and if it ends lower, it's exo. Like those are high school real common chemistry things, so maybe that'll jog your memory a little bit. But if you don't remember, that's okay too. And kinetics is about how fast a reaction is. It depends on orientation and speed. You'll learn more about it in this section. You'll have a table that looks like this, only it has a whole lot of values in it, like going down. And you're going to learn how to use, this is a generic equation, but you'll learn how to use a table to calculate this, and then to go back and plug in a row to calculate this. So you're going to use a table to use this equation. So this one's kind of not exactly really just an equation. It's kind of like you have a generic and you're going to figure out the exact equation for the exact table information that you're given. But that's the rate laws and the energy diagrams and the kinetics.